everyone to our session, Dev 261 Build Extensions with SAP BTP Kyma Runtime. My name is Marco Dorn. I'm in the product management team and the enablement and adoption group here at SAP of the Kyma Runtime. I'll just do a quick introduction and then hand over to my dear colleague Gaurav, who will walk you through the today's session. So what we would like to achieve here with the session is to give you a full walkthrough with regards to using Kyma Runtime in the context of the SAP BTP. So we will make use of a lot of different services like the Cawley CD service, Hana Cloud, and so on and so forth, and deploy a CAP application inside Kyma so that you can use it in your day-to-day life with this setup. We will, of course, have chat support, as it was said, on the TechEd webpage. We'll have a group of experts in there, and we will use our community page on the sap.com community later on to post as well the Q&A, of course, along with all the answers, so that if we miss one question here in the chat throughout the next 2 hours, don't worry about it. We want to answer this on sap.com afterwards. So I'll put the chat, the link to that tag in the chat. So follow the Kyma tag on sap.com so that you will be notified once the blog post is there. With that, I would say buckle your seatbelts, get your coffee ready, and I will hand over to Gaurav, who will take you through the scenario.
Thanks, Marco. Just a few words about myself first. I'm Gaurav, and I'm in the same team as Marco in the Kyma product management. So we work with customers and partners and help them implement extensions using the Kyma runtime. So let's get started. I'll start from what we are trying to achieve in this particular walkthrough session. So we are going to build an extension on top of Kyma runtime, but we'll be leveraging a lot of BTP services, as Marco mentioned. So we want to demonstrate here that you can build your cloud native solutions on top of Kyma runtime, and you should be able to leverage a lot of SAP BTP services to help have your extensions basically integrated well with the BTP ecosystem. So some of the key services that we are using as a part of this extension is the Launchpad service. So with that, we will have a central point of contact or access for all our SAP and non-SAP applications, as well as all the custom extensions either built on cloud or on-prem systems. For the storage purpose, since we are using a CAP-based extension or application, we'll be using the Hana Cloud database for storing all the required items. And then just as a additional effect, since our CAP application will be talking to other dependent services, so you want to also ensure that whenever there is some kind of a problem, we should be able to alert the respective SREs and developers so that they can take corrective actions. And for that, we are using the SAP Alert Notification Service. So you'll see that we will simulate an error so that we can see the communication is somewhere broken along the flow, and then how the alert gets generated and the corresponding developers gets notified. And we'll be also deploying Html5 application, and then for that, we're using the SAP Html5 application repository. We'll see that how we can trigger such a deployment directly from the Kyma runtime. Yeah, so this is the whole flow that looks like. So we have our Launchpad service as our central point of contact. Then we have our HTML5 repository where we are hosting the SAP UI5 application. It will be talking then to the CAP service that is running on the Kyma runtime via the destinations that will also be created as a part of the deployment of the HTML5 application. For the CAP service, the persistence is backed by the SAP HANA Cloud. And then as a kind of a mock where we are storing our orders just to simulate the whole flow, we are using a mock application, a serverless function in the Kyma runtime. And for the alert notification also, there is a small serverless function that takes care of generating the alerts whenever there is some problem with the processing in the CAP application. On top of that, we will also see that how we can orchestrate deploying of such a whole bunch of scenario using the CI/CD capabilities from the SAP ecosystem. We'll see that currently now SAP CI/CD service supports the container-based applications. So we'll leverage those capabilities to first build our Docker images, and then after that, deploy them on the Kyma runtime. Yep. So going further, these are some of the requirements that are required for going through this session. So you need some of the tooling installed on your work machine. The first is the kubectl. So you can run some of the kubectl commands to deploy some configurations on the Keema cluster. Then for the CAP application, you will need the Node.js version 14. We are also using JQ for some of the commands to do the JSON query processing. And then for building the images locally, you need to use a Docker desktop, and then you need to be aware of the terms of usage for Docker in enterprise. So let's get started. Yep. So in the first step, we are just doing the basic setup. We are doing basically a fork of the repository, and then also ensuring that our BTP sub account is properly configured. So the first step is to do a clone of this repository, and then do a fork, and then do a clone of the repository. So you can do the fork from here. You can select the appropriate your GitHub account where you want the fork to be generated. And after that, you can do a clone of that particular repository. So in my case, I've already done this, and then I'm just going through the steps. So we'll take care of the next part. So once you are able to clone the repository, you need to create a credentials directory inside the root of your the repository. So this will look a bit like this. You will have a credentials folder here. The whole purpose of this is that we'll be storing some of the credentials in the JSON and other formats, and we are ensuring that they don't get committed when you do any commits back to the repository. So they're a part of the git ignore. So that's why all the further steps where you are creating some credentials, you will store them first, the templates in the credentials, and then modify and add the data there. The next step is then to create the entitlements in your sub account if they are not already there, so that you are able to create the instances of the required services in the SAP BTP cockpit. Just to give an example, so we'll be creating the entitlements for the alert notification, continuous integration and delivery service, Kyma Runtime if it is not already entitled, and the Launchpad service, Hana Cloud and Hana Schemas and STI containers. So for that, you will need to go to your sub account. Just a moment, I'm going to refresh that. Yep. And once you are inside your sub account, you need to go to the entitlements. And inside the entitlements, you can do the configure entitlements, and then you can add service plans. And here you can select the various required services which are mentioned in the documentation in the GitHub repository. And then you can select the respective plans, and then you can add the service plans here. So that way, once you do this and then do a save, all these entitlements then are a part of your sub account, so that you can go ahead and then create the subscriptions and the instances for the respective services. So that's a part with there. And then after that, you will need to go ahead and then enable the Kyma Runtime. In my case, the Kyma Runtime is already enabled. So I will already see a link to the dashboard. But in your case, if you're doing it first time, you will see a possibility to enable the Kyma Runtime here. I can see the disable Kyma Runtime, you'll see the enable one. And then once you enable it, after a time of around 45 minutes, you will see the Kyma Runtime provision, and then you should be able to access and link to the dashboard. And so once you have generated a Kyma Runtime, you will also need to ensure that you have the appropriate access provision for your user who is going to follow this session. And then for that, you need to go to the role collections. And here you need to search for the Keema namespace admin. Yep. So you need to search for the Keema namespace admin, and then you need to add your respective user. So here you can search, you can do an edit. You can select for a user, and then you can do a plus here. And after that, once you save it, then that user is granted the access to the Keema Runtime with the namespace admin role. And then you will see that this is required for performing various steps as a part of the follow-up exercises. So you can see that my role is already provisioned. So similarly, you will see a same result once you have done the role collection assignment to the user here. Okay. So we are done with the assignment of the role collection. And after that, since we are using the kubectl command line utility to access the underlying Kubernetes cluster, we will need to have the kubeconfig downloaded so that we can configure it and then run the various kubectl commands. And for that, I will need to now go to my Keema cluster. And from there, I will download the kubeconfig. So I will go to the overview section back, where I have the link to the dashboard. And I will now, I'm inside my Keema console. And here on the top right-hand side, when you click on this person icon, you can see the various options, and one of them is to get the kubeconfig. So I can click on this and download the kubeconfig here. And then store it. So once you store the kubeconfig file, you need to ensure that your console environment is aware of that kubeconfig. So we do it via the export command. And here, when I do the export kubeconfig, my command line becomes aware that now I have this particular Kubernetes cluster to which I need to connect. And if I run some of the basic commands, for example, kubectl get namespaces, I should be able to see that this command is working fine. So that way, I'm kind of able to confirm that my kubeconfig is correctly downloaded and correctly configured, because I'm now able to connect to my Kubernetes cluster on which Kyma Runtime is running. So going back to the further steps, yeah, you can follow the different paths. So in case you are using a Unix-based system like OS X or other, you can do the export kubeconfig. Otherwise, for the Windows users, they can do the env kubeconfig and the kubeconfig file path. And the next step is basically we need to create a namespace here. The namespaces you can think of as a way of segregating the workloads inside a Kubernetes cluster. So they kind of provide you a virtual segregation for your workloads. You can do it on various criteria. You can do it either as a part of different teams working on different solutions or different extensions or different applications. At the same time, you can also do the segregation based on different end scenarios. So it's up to you, but this is a kind of a Kubernetes capability that helps you to ensure that you can segregate your workloads. You can also ensure that you can set up the quota limits for those workloads or those namespaces, so that you can kind of control the usage of the resources for your respective namespaces. The next step would be now to configure the Launchpad service. And for that, you will need to go to the service marketplace and search for the Launchpad service here. And inside the Launchpad service, you will need to create, so it will create a subscription. In my case, the subscription is already created, but when you're doing it first time, you will select a standard plan and then do a create here. So that way you are able to create a subscription, and then the subscription will end up reflecting in the instances and subscription section. So you should be able to see a Launchpad subscription created for you. And to access this Launchpad service or to go to this application, you need to ensure that the respective role has been assigned for your user. So again, for that, you need to go to the role collection section. And in the role collections, you will be able to see the Launchpad admin, and then you need to assign this admin to your respective user ID or the email ID there. So that way, then you are able to access the Launchpad admin service. Similarly, we need to do it for the other ones. Now we need to create a Cloud Foundry space. We are not actually deploying any applications inside Cloud Foundry. We are just creating this space because we need to then provision the SAP HANA Cloud Database. Currently, the SAP HANA Cloud Database can only be provisioned from the Cloud Foundry. So that's why we need to create this particular space. So you need to go to the Cloud Foundry part, back to your sub account. And my bad. So I'll just go back to my sub account. I just navigated to my global account. And then here in the Cloud Foundry, in the spaces, you will see that there is not any space. And then you can create a space called dev. And inside the dev space, then we will go ahead and then provision the SAP HANA Cloud Database. Similarly, we will also provision or configure the continuous integration and delivery service. So we'll be using the continuous integration and delivery service for building various pipelines that will create various artifacts and then also do the deployments on the Kyma runtime. So we'll see that in a while. But for now, as a first step, we will create a subscription and also assign the appropriate role so that we can later on access this continuous integration and delivery service application. So very similar to how we did for the Launchpad, we need to search for the continuous integration and delivery service here. We need to do a create. Yeah, in my case, it's already created, but you'll see the option to do a create here. So once it is created for you, you need to go back to your role collection section under security and look for a role collection that is called the Ci Cd administrator, and then assign it to your respective user. So in a very similar way, we did it for the Launchpad and the Kyma Runtime. Similarly, we need to assign it for the Ci Cd service part. So with this, we are done with the basic creation of the subscriptions that we were using in the following up exercises. And now we need to look up at the creation of the SAP HANA Cloud Database. So for that, I will now go into the Cloud Foundry space. So I'll go to this. In the Cloud Foundry space, I will navigate to my dev space. And here I can see the SAP HANA Cloud section on the left-hand side. So I will go ahead and then create a database. So I won't be creating actual database, but I'll just showing you the steps that what all you need to do for creating the database here. Yeah. So I'll just get navigate and select the SAP HANA Cloud SAP HANA database part and then move forward. So here I will provide a instance name. Then I will provide a password for my admin user. Then I will go to the next step. So I won't be doing any changes here. This is just for the example scenario. So I will keep the default resource and the storage capacity. Then go next. No changes here. I'm not configuring any scalability part as of this one or the replicas. And in the advanced settings for this particular example, we are just doing a allow all IP addresses just to ensure that it's a simple scenario and then can be easily implemented. And then I will do a review and create. So this is all you will need to do for creating the SAP HANA Cloud database. And once you do this, it will take some time to get the actual database created. So once the database is created, you will then require to do next to create an instance of the SAP HANA schemas and HDI containers services. So for that, once you see the database is up and running, you need to go back to your sub account and go into the service marketplace and select the SAP HANA schemas and HDI containers, and then go ahead and then create an instance. So in this case, you will select the plan HDI minus shared and then provide an instance name and then do a create here. So in my case, the instance has already been created. So once the instance has been created, you will need to generate the keys so that you can use those keys for accessing the database from the Keema deployed CAP application. So then we will navigate to the instances and subscriptions part so that we can generate the keys for the HANA schemas and HDI containers instance. I will go to the instances section now. And here in the instances section, I can see one instance that is for the HANA schemas and HDI containers. And here I can see that you can go ahead and then create a service key. So just provide a name that is required in the instructions, and then you should be able to create a service key here. In my case, the key is already created. So once the key has been created, you will need to do the view key and copy the JSON, because then we will be using this JSON and then creating the secrets on the Keema cluster. Yep. So we are done with all these steps. And what we need to do next is we need to now go back to our repository that is we have forked and cloned. So here in the template section, you will see that there is one vcap services JSON file. You need to copy this file and then create a copy in the credentials directory. And then in the credential directory, you will need to replace the JSON that you just copied from your service key in the HANA section for the credentials part there. So once you do this, this is gonna look a bit like this. You should be able to see all your credentials created here. and then copied under the credentials section. So with that, we are now able to set up our credentials on our repository, and later on we will then apply it on the Keema cluster. So with this, we are able to do the first initial step. We are able to do all the required configurations from the BTP account side so that we can move forward and do the follow-up exercises. The next part is creating the access UA service instance. So we'll create the authorization and trust management service directly inside the SAP BTP Kyma runtime. And this will be used for ensuring that the access to the CAP application from the HTML service is secured. So for that, we will need to simply apply this resource. And you can see that it's a kubectl command where we are saying that in the namespace CAP, you need to do a apply of this particular resource. And if you look at this particular resource, you can see that here we are requesting to create an instance of the access UA type. I will now just show you how this resource looks like. I will go inside the resources section under HTML5, and I will open the access UA service. So we are saying that we want to create a service instance, and then the class or the type of the service is access UA, and the plan is application. And then we are providing certain parameters. We are providing the access app name, the tenant mode is dedicated, setting up a few scopes and the role template, and also creating a role collection here. So this role collection then will be created in the BTP cockpit, because then we are ensuring that only users that have been assigned with this particular role collection then will be able to access our CAP application. Then we are creating a service binding. The service binding is going to create a service key for us behind the scenes so that we have the appropriate credentials then to use in the later parts of the application where we are going to deploy the CAP application. Okay, so you will run this command and then do apply here. So once you do this, it will create a service instance inside the CAP namespace. And then from the Keema console, you can have a look at there. One thing to mention, you can also do it from the Keema console. As a part of this section, we are doing most of the steps from the command line, but it's also possible to directly do it from the Keema console UI, if you prefer to do it from the user interface. So inside the service management instances, once your instance has been created, you will see the instance getting reflected here. And if I click on this instance, since we already also created the service binding, so it will also create the credentials for us. And then you should be able to see those credentials. And then if you decode them, you should be able to see the values for those credentials seeing here. And the next step now we need to do is we need to create a Kubernetes secret using some of the values from those credentials that get created. So for that, we will copy the HTML5 config secret YAML file from the resources directory under HTML5 and put it in the credentials. And we will copy the client ID, client secret, and the URL. So this is the URL for getting the OAuth token. So we'll be configuring those credentials so that our applications and then the jobs that we're going to run later, they should be able to consume those secrets. And also we need to copy the cluster domain so that the CAP application has all the required parameters, including the URL that it needs to send to the Launchpad and HTML5 service. So the cluster domain is nothing but basically a part of your host name for the Keema console. So after the console part, this is how your cluster domain going to look like. In your case, it will be something different, but essentially after console, you can copy this value and then you can create those parameters. So if you go inside, once you have copied it in the credentials folder, you will see that here you are able to replace your client ID, your client secret, and the token service URL, which is basically this part, and then the URL of your CAP application. So once you do this, then you should be able to create the secret containing all the appropriate values. So for that, yeah, that's the time now to create a secret, and then I will simply do a kubectl apply, and then in the namespace CAP. So if you look back at this directory, I'm just saying that I want to create a Kubernetes secret, which has a appropriate name, and then it contains the string data containing all the various applications, all the various configurations that we need to configure for setting up our application. So once your secret has been created, now we need to create the secret for the VCAP service. So for that, we need to open our VCAP services JSON file. If you remember, we already configured the HANA credentials, and now is the time to now configure the Access UA credentials. So for that, you can basically use the jQuery here to ensure that you are able to quickly copy the credentials. So for example, if I run this command just to get the secrets in the output JSON file, yep. So you can see that in the JSON under the data attribute, I can see all the various values, and then they are base64 encoded. So what we are doing here is in this command, we are saying that please get me a secret whose name is cap orders access UA binding in the namespace cap, and give me output of type JSON. And I want to then apply the jQuery to the data attributes, which is here, and map all the values and do a base64 decoding. So with this, you are able to get a result that looks like the actual values. And then you are able to copy those values and then provide them inside your credentials part of the Access UA section. So here you should be able to copy those values and then provide entry there. So that way, then we have also our VCAP services secret, and then we can now then apply this secret and then create it inside the Kubernetes cluster. So this is how then I'm going to, if you're using a bash shell or on a Unix-based system, so you can say that you want to create a secret that is of type generic. So just to mention, in Kubernetes ecosystem or Kubernetes cluster, there are various types of secrets. You can create the secrets for your Docker credentials, for your TLS certificates, and so forth and so on. But in this case, since we are creating a secret for our key value pairs, we are just using a secret of type generic and then providing a secret name. And we are saying that take the values from the secret from the literal, the name of the key VCAP services, and the value is coming from this particular file. So once you run this command, you should be able to create a secret that then gets created in the cap namespace. So if I just show you how this secret looks like, in case you want to verify, yeah, you can always. So once a secret has been created, you should be able to verify that. You can see that in the secrets now we have a key called VCAP services, and the data is the whole file contents of that VCAP services JSON file, and it's base64 encoded by default, because that's how secrets are stored in the Kubernetes ecosystem. And since we created a role collection, so we also need to ensure that the user who is kind of doing this workshop or doing this session, he also has the appropriate access permissions then to access this CAP application. So for that, you will need to go back to the BTP cockpit inside the security role collections. So you will see now that there is a new role collection that has been created, and then you need to assign this role collection to your respective user. So the way we have done it right now for this migrant user. And with that, we are able to do the first part. So the next part is basically to run the application locally. And I'm going to skip this section, but in case you are interested, you can run the npm command. Since it's a Node.js based CAP application, you can install the CDS SDK and also install the required dependencies, and then do a CDS watch component so that it will start running your CAP application. And then you should be able to access it on the localhost port 4004. And you can take it a step further, and you are also able to then access it, the actual HANA Cloud database, if you export the VCAP services credentials inside your run environment. And in the next step, we will go and configure the SAP Ci Cd service. So the aim here is that we are able to configure all the deployments, all the pipelines in such a way that all our artifacts are getting built automatically via the SAP CI/CD service. At the same time, we are also able to do the deployments for our CAP service, run the jobs, which will configure or deploy the database, and also deploy the HTML5 application via the CI/CD pipelines. So the advantage here is that any changes that you do into your code and you do your incremental developments, you can simply push it to the Git repository, and the pipelines will automatically be triggered, and then the new changes will be applied automatically to your Keema cluster. Okay, so now we will access the SAP CI/CD service. But before that, in case you are using a GitHub repository that is not public, you will need to create a personal access token so that the SAP CI/CD service is able to pull the code and then do a build artifacts for your respective GitHub repositories. So for that, you need to go to your profile in GitHub, or in a similar source versioning system. They might have a similar kind of instructions there. And then you need to go to the developer settings. You go to the personal access token, and then you can create a new token here. So in my case, the token has already been created, and then you can see that it is expires on this particular date. But for similar case, you can go ahead and then create a token for your user. So once you have created a token, then you need to configure these credentials on the SAP CI/CD side. So now I will access the SAP CI/CD service. So I will go inside my sub account, go to the instance and subscriptions. And here I can access the continuous integration and delivery application. So I will simply go to the application. And here you will start creating all the various credentials. So you will need to start with the Git credentials. So in my case, I'm just showing you how it looks like. You provide a name that is given in the instructions, and then you select the type of basic authentication, provide your GitHub username, and then the token is provided as a password that you just created just now. So this covers our Git access in case you are using a private repository. And after that, we need to create a Docker credentials. So in a similar way, if you're using Docker Hub or any other private registry, you can create a personal access token on the Docker side. And after creating that token, you will create a JSON of this format where you will provide the URL of your Docker registry. In case you're using Docker Hub, you can use the index.docker.io. And then you provide a username as your Docker ID, the password as your token, and you will create a credentials in the SAP CI/CD side. So in this case, we will create a credentials of type secret text. So it's going to look like a bit like this. So you'll see the name and the type is secret text, and then the secret is this whole JSON that you just enriched in the previous step. So this will cover our Docker credentials. After that, we need to configure the kubeconfig. Now the kubeconfig that you download from the Kyma runtime, this has a token which gets expired after every 8 hours. This is meant for a security reasons. So that's why it doesn't make sense to use the same kubeconfig for configuring your CI/CD pipeline, because your CI/CD pipelines will be running continuously for days and months until your project is being developed. So it makes sense to then create a kubeconfig that is long lasting, that has a token that doesn't expire. So for that, you need to follow a different set of steps. So there is a concept in Kubernetes where you can create a service account, and you can set up the role bindings and access so that you can have a machine level access to or a machine level permissions for your service account to create or deploy the applications on your behalf. So basically, with this whole set of instructions, you are creating a service account that can, for example, create the deployments, delete them, update them, or create the pods and do various steps which the pipelines will be doing behind the scenes for you. So you will create a Keema service account and a kubeconfig. So once you have created a kubeconfig that does not expire, you will also create a credentials in the SAP Ci Cd service as a secret text, and then we'll call it the Keema cred. So very same to how the Docker cred looks like, but in this case, the input will be the kubeconfig YAML. So you will create a secret text, and then you will copy paste your kubeconfig YAML here. So that way you have a secret which has a kubeconfig file that does not expire, and then your pipelines are able to reuse it again and again, so that don't hit any kind of problems when doing the deployments on the Keema cluster. Okay, so with that, we are finished with our the first three set of credentials that we need to configure. And after that, we will do add the Github repository. So now you will configure the repository so that you are able to instruct the Ci Cd service from where it should be pulling the code. So for that, you need to provide the clone URL for your Github repository. In my case, I provided my URL. And then yes, you select the credentials. In case it's a non-public repo, you can select the Git credentials, and then you can do a save. So once you do a save, you can go inside this three dots on the top right hand side, and then you can click on the webhook data. So here we have the payload URL and the secret. You will need to copy those values and then create a webhook on the Github repository side. The reason for being that is whenever there is a new commit that is being pushed on the Github repository, it will then send a notification to the Ci Cd pipeline on this webhook URL, so that the pipelines can automatically get triggered. So for that, you will need to go to your repository. I will just go to my section here, my account, so that I can access the repository there. And I'll go inside the settings part. Here I will look for the webhooks. And you can see that I have created a webhook here. So in a similar way, you should be able to. Yep, I just don't want to do it now, but yeah, I can just do edit so that you see how it looks like. Okay, but in the end, yeah, you should be able to configure the webhook and then provide the webhook data and the secret so that the webhook gets created for you. So we have created the webhook now, and then yeah, provided the secret there. And the next would be that we'll be creating the Ci Cd jobs. So we'll be creating the various jobs for doing various tasks. Just a one note there, in case you are using a free trial or a free tier service, you will not be able to create more than 2 jobs. So that's why you will need to follow the other exercises either via the kubectl or the Helm install. But in case you are using a normal sub account, you should be able to create more than 2 jobs and then also automate the whole pipelines. And one more thing to note, so when at this point of time, when you are configuring your various jobs for the Ci Cd pipelines, you'll see that the jobs will fail if you trigger them right now. The reason being that some of the parameters in your code need to be changed. For example, your Docker ID and other values, so that it can pick up the right values and then have the right set of instructions to create a Docker image and then push it to a Docker registry. Otherwise, it will not be able to find your Docker ID, and then it will complain for that, and then it will fail for those very reasons. So we'll start with configuring the jobs part. We'll start with that cap order service. I'll just directly go to the job definition to show you how and what configuration we need to provide there. So here are my 4 jobs that have been configured. So I'll start with the cap order service. And if I do edit here, I can see the job name provided there, then the repository. And then in my case, I choose a different branch, but you can keep whatever branch name, main or whatever you have planned for that, and then provide the same branch name here where you're going to put your changes. That's the main thing, that it should be the same branch where you're doing all the changes and then pushing them to the repository. The pipeline is then the container-based pipeline. So that's all we need to provide there. I'll keep all the defaults for now. And here for the build part, we provide the container registry URL. So this is required because once the Docker image has been created, it will be pushed to a particular registry. And then in case we are using Docker Hub in this scenario, for my case, I'm providing the Docker index.docker.io. Then I provide my container image name. So this is my Docker user ID and then the name of my image. I'm providing a latest image tag, and then I'm providing the Docker credentials so that the pipeline has the right permissions to push the image on my behalf. So for the build part, I will provide the Docker file. So it will be residing inside a resources service Docker file. And if we have a look at that, you will see that the Docker file contains all the instructions to create the end artifact that will be used for deploying the CAP service. So if I go inside the resources, service, Docker file, so I'm using a base image. We'll come back to that later. But you can imagine that when you are creating this Docker image, there is a possibility to do a multi-stage build so that you can run some of the commands to do some basic build and then copy the created artifacts into another Docker image. So I'm using this cap UI5 tools as a base image. And then I'm saying that my work directory is /app. Then I say copy everything inside the components into the app directory. So this is basically this components directory that gets copied. And then I run the CDS build command. This CDS build command is coming from this cap UI5 tools because it contains various toolings like CDS and then UI5 and other command and utilities. So that makes it easier for me to run those various commands to build the artifacts. So once my build is done, then I will use a lightweight node image to have as my actual image that I use for running the application. I'll set my environment to as production. So in this case, now I use a different working directory, and I will copy everything that get generated in the previous step here from app-gen SRV to this current working directory. And then I will run the npm install to install the dependencies. And as a part of this step, I'm saying that I'm going to run this application on port 4004. So I'm going to expose this port from my Docker container. Then I create a user node, which will be running this application. And then I instruct that for running this Docker container, the command to be used is npm start. So this is basically how you define all your instructions one by one in a Docker file so that you can get a Docker image, which is your binary artifact that will actually then run your application. So this is what we have done here. So this finishes our build part. Now the next will be the release part. And in this case, we are going to deploy the applications on the Keema cluster. So we are using the Kubernetes credentials that we previously configured, the Keema cred, and we are saying that please deploy it on a cap namespace. And you can have the option to use either the Helm3 or the kubectl command. So we are using the Helm3 here because it is more configurable. You can have the same Helm charts which are used for deploying your applications defined once, and then you can use a different set of values for deploying on different environments and landscapes. So for example, you can use the same templates for deploying on your QA on your production landscape. And then I define the chart path, so which is inside my resources, services, Helm, and then cap order service. And then I provide a deployment name and then the Helm values. So let's quickly have a look how our Helm chart and Helm values looks like. So I'll go inside resources, service, Helm, and this was a path. So you can see that this is a Helm chart. So Helm is basically a way of deploying the Kubernetes configurations, and then it can template them. So we'll quickly have a look what does template means here. And if I go inside the templates and if I look at my deployment, you can see that this is a standard Kubernetes deployment, but it doesn't have the actual values, but it has those templates which will be taking it from the values.yaml file. So one thing of interest would be, for example, what is the source of my container image? So I'm saying that it is coming from values image repository and the values.image tag. So the values are provided here. You can see that values.image.repository is my image, this Gubby/cap auto service, and then the tag is latest. So the advantage here is that, as I mentioned, you can have the same templates, but you can have different values YAML file for different environments. You can configure different resources and then do various different configurations as per your needs. So that way it makes it quite easier to deploy the artifacts in a kind of a continuous way. So this is all about our Helm chart, and then we just do a save here. So it's already saved in my case. I don't need to do anything different. So that finishes our deployment or configuration of the job for the cap auto service. Let's have a look next what we need to do further. So now we need to deploy the orders HTML5 deployer job that will deploy the HTML5 application. Yep. So just to mention that we have kept it here optional because, as mentioned, there is a limit of 2 jobs, and then in case you decide to maybe use the job for some other purpose, then you can do it either directly via the kubectl or the Helm commands from your laptop or machine. So similarly, we will also go ahead and then create this application. We'll again define the container-based application section here. And in this case, we will create a build from the resources HTML Docker file, because in this case, this is a different artifact. So we have a different set of instructions for it to be created. And in a similar way, then we will define the instructions for doing the release or deployment on the Keema cluster. So just to have a quick look how it looks like. I'm just going to do an edit. So yeah, I'm just again using the same branch because this is where I'm putting all my changes. And here are the instructions for deploying it on the Docker registry. And after that, the instructions for the Docker file. So in this case, if you look at the Docker file, you will see that it is doing a different stuff as compared to for the cap service. So here again, I'm using a base image and then copying some of the components or the directories into my current directory. And then I'm running some of the commands and then using a UI5 build, because we are building a HTML5 application. So we are using the UI5 utility, which is again packaged as a part of this base Docker image. And then for running the actual, creating the actual artifact, we are again using a Node 14 Slim. And we are copying the created artifacts from this step into this directory. And then we are copying also the resources HTML5. And after that, running npm install and then exposing it and then doing npm start. So a different set of instructions, but you can see a very common paradigm where you can build your required artifacts with a heavy image, with the image that contains all the tooling, and then you can copy them into a lightweight image so that you don't require them during the runtime. Okay, and then similarly, we will then go ahead and then create a chart for this application so that when it gets deployed, it will be able to deploy the Kubernetes job as a part of this Helm chart. So this will finish our orders HTML5 deployer part, and then we will see how the orders DB deployer looks like. So it is again it's not a deployment, but it is a Kubernetes job that will actually deploy the database as when it's run as a part of the Kubernetes job there. So very same set of configurations, but providing the different paths. So we will again provide a different image name, use the same credentials, because then it will be getting pushed to the same Docker registry. We're providing the link to the Docker file here. And then your build path is done. Then we go to the release section, and here we specify our credentials, the namespace, and then the tooling, the chart path. So this is a different chart with different set of configurations, and then a different deployment name. So that way we are able to then configure our job that will also then deploy the database required for our application. Okay, the last job that we need to configure is the cap UI tools. So this is the base image that we are using for all our various artifacts, and it contains various toolings like the UI5, the CDS, the OpenSSL, JQ, so that we can run all those commands as a part of our Docker instructions or Docker file. So the cap UI tools, and then this is quite light. And in this case, there is no release. So we just are doing the build part here. So we are providing the image name, and then we are saying that we just want to deploy it on the Docker registry. So you can see that release part is off here. One thing to note is that this is the only job that you can directly run from here, because there are no configuration changes required. So once you configure this particular job, you can just click on the run part and it will start getting triggered. So there won't be any failures for the cap UI tools because it's simply building an image, and then it doesn't require any changes into the files. Okay, so with that, we are done with the cap UI tools. Yeah, so you can trigger the cap UI tool to build and push it to the Docker registry, because it is going to be used for the other jobs. So it makes sense that it is already existing in the Docker registry, so that when the other jobs run, they don't fail because they say that there is a missing image. Okay, so we'll go to the next part. So now we are doing the actual generations. We already did it for the base tool image, but in case you are not doing it via the CI/CD pipeline, you can do the Docker build by yourself on your laptop, and then do a Docker push to your Docker account. So once you do that, your base image will be then generated. So yeah, these are the commands you need to run locally. You need to replace it with your Docker account. So you can provide your Docker account here, and then you can, when doing a push also, Docker push, you can provide your Docker image, Docker account here. So the next one now is generating the cap database. So we'll be basically deploying the database required for this application. So configuring the schemas and also enriching it with some initial database entries. So some of the initial work that is required, we have already done it in the previous steps. So we have created a Kubernetes secret called orders bcap services, because when you deploy this database, it needs the access to the HANA cloud database, and that is provided by a part of this secret. So if you look at the job definition, you will see that it is relying on this secret so that it can access the credentials and then deploy or deploy the database using those credentials. So the first thing you need to do is you need to basically change your Docker account in the resources DB Docker file. I'm just going to show you how it looks like. So this is in my case, but if you look at the main branch, you will see that it will show you that your Docker account, you need to change this entry, and then you will then change it to your Docker account. So it will get reflected here like this, and then do a save. So currently we are not doing a push, so none of the actual jobs are going to get triggered. So we are just currently preparing the various deployment options. And in case you are doing it via the SAP CI CD, you will also need to modify the values.yaml file so that it also tells for the release part to which Docker image to be used. So you need to go here in the values.yaml. You can see that I provided my image, but if you look at the actual, when you do the first fork of this repository, you will see that there is an entry for your Docker account. Just gonna look like a bit this. Yep. So this is the deployment option. We are just doing the save the changes. No job is getting triggered, but we are just currently ensuring that all our resources are correctly configured so that when the jobs are getting run, they run successfully. Now, in case you are not using the SAP CI CD option, you can do it via the kubectl. For that, you need to first build the image. You can provide a Docker build command and then do a Docker push so that your image gets stored into your Docker registry. And after that, you will then change the deploy job YAML, which is basically used for deploying the Kubernetes job. So in that case, you will be modifying this file. You will changing your Docker account here. And then after that, you will do a kubectl apply. You'll follow this command to trigger the job for you. And the third option is to do it in a similar way via the Helm. So again, in case you are doing by the Helm option, you will first build the image by yourself, and then you will replace the Helm values.yaml. And then after that, you will run the Helm install command to install it as a Helm chart. Now, when the job has been completed, you can also verify that it ran successfully. So you can copy this command. And you can see that you should be able to see one completions. So this kind of gives you a confirmation that job was able to be completed successfully. And if you are curious, or in case you need to troubleshoot, you can also have a look at the logs of the job in case there is some mismatch in the credentials, or for some reason your job is not working as expected. So you should be able to, yeah, in my case, the logs were old, so you won't be able to see it here. But in case you have it already there, you should be able to see all the entries describing that it's able to enrich the database there. Or in case there are some errors also, you should be able to see it there so that you'll be able to fix and then move further. So this will finish our deployment of the database part. And then now we will move to the next exercise. And in this one, we will be deploying the HTML5 application. So again, we will deploy the HTML5 application as a Kubernetes job. So you will again have the option to do it either via the CI CD, or do it via kubectl, or do it from the Helm command via installing a Helm chart. So just for the, in case you are curious how this job is working, so this is relying on the HTML5 app deployer package. So this is an npm package that is available on the npm repository provided by SAP. I don't see the readme here, but for some reason it's not coming up. But essentially, you will be able to see that this is where you can see all the instructions, how the actual job has been created. Let me try the refresh one more time. It's coming up now. Maybe it took a while. So I'll just go down to the section of the Kubernetes part, because that is what we are doing essentially here. So you should be able to see that we are running it as a Kubernetes job, and then deploying it using the HTML5 deployer, and then providing the various configurations. So we are following this standard pattern of deploying a HTML5 application using a Docker image on the Kubernetes cluster. So there are some of the backend destinations that get deployed as a part of this deployment when this job is being run. And then you will be able to confirm them from your BTP cockpit. So as a first step, you need to modify some of the files. So you need to modify your Docker file so that it is referring to your Docker account for the base image. So if I now go back to my VS Code, so you are able to replace this Docker account here. That's the first step that you're doing. And after that, you need to create the service instances for the destination HTML5 application repositories. So these are, you don't need to do any changes there. You just need to do an application of this via kubectl on the cap namespace. So let's have a look at that, what we are creating in this case. So if we go to the service instances section, you will see that I am creating a service instance of type HTML5 apps repo, so that we are able to deploy our HTML5 application. And we are using a plan of type app host or application host. Then we are creating a binding so that we can create the required secrets. The second service instance we are creating is for the destination, because when we are connecting or making a call to the CAP service from the HTML5, it is done via forwarding it the call from a destination service in SAP BTP cockpit. So that's why we need a destination service instance also. Again, we create a destination and then also create the appropriate binding so that we can get all the credentials required for interacting with the destination service. So you will simply apply this and you should be able to then see those instances getting created for you. So if you go to the Keema console, you will go to the instances and services. You will see the CAP orders app instance and the CAP orders destination service instance getting created for you. And then also the corresponding credentials will be created for you here. Similarly for the destination case. So that will finish our basic required service instances, and now we'll go to a deployment section. So the deployment part for this one is also very similar to what we did for the database deployment. And here, in case you are using the CI CD service, you just need to replace the values.yaml, your Docker account, so that once you do the save and then later on when you do a push, it's able to pick the correct Docker ID for your account for the deployment part. And for the kubectl one, you need to first do a Docker build to build the image, and then do a Docker push to store the image in your Docker registry. And after that, you need to replace the deploy job to refer to your Docker account. And on top of that, then once everything is done, all the things are correctly replaced, then you need to do a kubectl apply to trigger the job. Same thing with the Helm, very similar steps. First build the image, and after that, replace the values.yaml with your Docker account to basically point to your Docker ID. So again, if you want to verify if the job has been run successfully, you should be able to do it with the HTML5 deployer part. So you can see that one of completions. And in case you face some issues or you want to see that what exactly happened, you can check the logs also by running this command. In my case, I run the job yesterday, so I won't be able to see it today. Yep, the pod might have got replaced. But yeah, when you run it first time, you should be able to see that what all instances it is creating and what all is getting deployed as a part of this particular job. So that finishes our section for deploying the HTML5 applications. And after that, we can go and deploy, we can go through the build and deploy CAP service section. So in this CAP service, we are basically creating multiple resources on the Kubernetes cluster on which Keema is running. So we are creating a typical Kubernetes deployment of the CAP service to run it as a pod on the Keema cluster. Then there is a service which is exposing it internally. And then there is an API rule which is exposing it over the internet. So for that, let's first have a look at those deployment files, how it looks like, so that we can come back then to the setup part, just to show you what exactly is happening there. So I'll just go to the service part and open the deployment YAML. So the first one is basically we will be creating this deployment file or the deployment YAML, and then we will pointing to our Docker image that gets created in the previous steps. So this will create a pod which will run our Docker container and then expose it on the port 4004. And we can see that it is taking the secrets from the orders vcap service, where we have created the vcap underscore services secret and then stored it. Then there is a Kubernetes service to expose it internally. And then the selector is the same app. So basically with the selector, we are seeing that this service is acting as an internal load balancer for all the pods which have this label. So you can see that this is a label that we provided here. So based on this selector, so this is how this service is able to identify to which pod it needs to then forward the workloads or forward the request. And then there is an API rule with which we are exposing it over the internet. So it gets exposed over this host, and after that is the Keema is a Keema cluster domain, and it is referring to this particular service. So it knows that it needs to forward every incoming request on this particular host to this particular service. Yep. So this will then create our various resources required for deploying the CAP application. Once we are done with that, so now let's look at the actual setup and then do the actual deployments part. So for that, again, we need to modify our Docker file to point to our Docker ID, the Docker ID of the user who is running this session. So you will again modify it to use your CAP UI5 tools, so that you know that what you are building and from which resource you are using those Docker images. And if you are using the CI CD section, you just need to replace the values.yaml your Docker account so that it can take care of the release part. And then you need to commit and push the changes to your repository. So once you do a push in this case, then your actual jobs will be triggered and then they will be deployed. So the other option is to deploy it via the kubectl part. So in this case, you can first do a Docker build and push. So you can build your image and then you can push it by yourself to your Docker registry. And then later on, you can apply the kubectl command to create the various resources via the deployment YAML that we just saw. Similarly, for the Helm part, you need to modify the values.yaml with your Docker account. So yeah, since it's coming multiple times, we can show it. So this is a values.yaml. Again, very similar to what we saw for the previous steps. It will look at like this, and then here you will replace your Docker account with your Docker ID. And yeah, you can then run the Helm install. So one thing to note, in case you are using the Helm option, then you need to have the Helm installed on your work machine. So the end result will be that your CAP service will be available over the internet on this particular URL. You can also check it from the API rules. So if I go to my namespace in which I have deployed all the things, and I go to the discovery and network section, if I go inside now the API rules and click on this, I should be able to access my CAP application. So it is currently being authenticated, so I won't be able to access it directly. I will need to either have a token or I need to access it via the HTML5 application.
Gaurav, one question from the chat, maybe at this point, now that we have the app deployed in Keema. So the question was, the app will be now running in the Keema environment while the destinations are in the Cloud Foundry environment. How will these two be connected?
Yeah, so they too will be connected because from your HTML5 repository, when you deploy the HTML5 application, you configure the destinations as a part of that. And whenever you are accessing your HTML5 application and requesting to get the data, it will look up the destination, and then from the destination, then it's able to understand to which service it needs to access. So maybe I'll show you that, because I think that will be more clear from there. I will start with the HTML5 part. I need to go to the credentials, the secret. So if you look at this, here we created the backend destinations, and then there is one destination called CAP orders Keema SRV. So this will be created in the BTP cockpit. And the URL for this destination is the CAP order service that is running on the Keema cluster. And my HTML5 application has been configured to refer to this destination when it is needs to access the orders data. So whenever now, if I go to my BTP cockpit and look at the destinations, I need to refresh it again because we haven't accessed the cockpit for a while. So bear with me, please, here. Yep. So these are destinations that get created here. And if I just do an edit, so you can see that this destination is actually referring to my application running on the Kyma Runtime. So this is how it is connected. My HTML5 tries to access the data via the destination, and then the destination then is configured with my CAP service running on Keema, and then that's how it kind of gets forwarded to my application running on the Kyma Runtime. So I hope that answers it. Yep.
Thank you.
Okay. Let me first do a discard here. And then let's move forward. Yeah, so we already saw that we are able to access the CAP order service via it being running on the Keema and then exposed over the internet. So this kind of finishes our whole part of deploying the CAP order service on the Keema runtime. And next would be now to configure the Launchpad so that we can have our HTML5 app available there. And then we can create a site. And after that, we should be able to access the site and access the orders data. So let's go to the configure Launchpad section. And for that, we need to now access the Launchpad subscription and then the Launchpad application. So I will go to my instance and subscription section. And here I will access my Launchpad application. So the first step you need to do here is create a new site. Yeah, it's already created in my case, but you will go ahead and then create a new site, provide the appropriate name that is mentioned in the instructions, or you can provide your own preferred name. And after that, I will need to first go to the provider manager to do a refresh option. So if I go here, so I can see my HTML5 apps available here, and then I can do a refresh here to ensure that all the latest changes are being refreshed there and it's aware of them. And after that, I need to start adding the content for my HTML5 app. So I'll go to the content explorer and then do add to my content. So in my case, I have already done that, but yeah. So I'll go to the content explorer. So this is my content that has already been added. So you can see that you will see a add to my content, but in my case, it's already there. So yeah, but you should be able to follow the instruction, then edit the content there. If I go to my content, then I can also create a group here. So in my case, the Keema group has already been created. Otherwise, you will create a new group called Keema and then assign the apps here. So yeah, this has been assigned. Otherwise, you'll see, I think, a plus icon here that will instruct you to assign the app to this particular group. So then I will go back and then I will also access or add the access for everyone with this role to this particular HTML5 app. So these are the steps I need to do for configuring my Launchpad part. And once I'm done with all of these steps, then I should be able to launch my site. And you can see that it has a Keema group, and then the orders application is the part of this particular group. And if I access on this one, I should be able to see the existing orders for my CAP application. Yeah, so these are some of the orders I did as a part of doing some previous testing. And then, yeah, that's how now I'm able to configure it on the Launchpad and then create it via get the data that is existing on the or running on the CAP application deployed on the Kyma Runtime. So this will finish our HTML5 app to the Fiori Launchpad. So we are able to do it successfully. And the next step, we are taking it a step further, where the Fiori Launchpad app or this particular application is only for reading the orders data. So we now want to ensure that there is a separate endpoint that is secured with Auth that is running on Kyma Runtime, and that is only used for submitting new order information. So let's go ahead and then follow that part. So in this case, we will apply we will modify our API rule to have then the auth authentication for the submit order part. So our current API rule looks like this, where everything is without any authentication. You can see that the handler is no, which means that there is no check or nothing applied there. Then we will modify this part to have a different access strategy for the external URI. And then we say that we want to have the auth to introspection, and then the required scope is submit external order. So that you can do it via the API rule external, you simply apply this modified API rule, and then it will modify it for you. So once you do it there, you can see the API rule looks a bit different. If I do an edit, in my case, it's already applied. So you can see in the order section, everything is no op. So there is no authentication, and it can support all the requests. But in the external, we say that we want to have the auth authentication, and then the required scope is the external order, submit external order, and we only support the post method here. So this is what we need to do here for securing the submission of the orders via the CAP, but that is not the end of the story. Now, for example, if I need to access or create an order there, let me first invalidate the token here. Now I'm trying to post the order here on this particular URL where my CAP application is running, and I'm saying that I'm putting it on the external submit order. So I should see the unauthorized part. Yep. So now we need to have since this authentication is happening with the auth server running on the Kyma runtime itself. So we need to have a Auth client and the corresponding secret from the Kyma itself. So we need to configure that, and let's see next how we can configure it on the Kyma side. So here in the configuration section, you can go to Auth clients, and then you can create a new Auth client. I'll just show you how mine looks like. Yep. So you can specify the response as of type token. Then the grant type is the client credentials. Then the scope is a submit external order. So once you do this creation, you will get a client ID and a client secret. And with that, you are able to then make the calls to submit an external order. So this is kind of just an extension of what we have done so far with the CAP service. We wanted to also demonstrate that you can, if you want to have a machine-to-machine communication, you can use the OAuth capabilities that come with the Kyma runtime, and then also make the API calls and then secure those APIs via that particular OAuth credentials. So let me now go back and let's get a new token. So I've already configured my client credentials and client secret and the Kyma OAuth URL. So this is basically your OAuth2 and your Kyma cluster domain / OAuth2 / token. And I also provide a scope. So let's quickly get a new token. Let's proceed. I want to use this token and then do a send. So you can see that now it is working fine, and then it is all successful. So this is how then you can also configure the OAuth for your various APIs, and then also segregate the different URI paths in case you want to only secure certain paths with the OAuth authentication. The same thing can be applied for JOT also. So in case you are using an external identity provider, you can do the same thing with the JOT tokens, and then you can configure the various identity providers there. So for example, I can always go ahead and then select a JOT and then provide an identity provider, the keys and the JWKS URI, so that it can be authenticated against that particular IDP's token. So that finishes our OAuth authentication part. Let's go back. So yeah, here the console, the instructions are to run it via the curl. So you can do it via the curl command. I just did it via Postman just to make it easier to follow there. And with the OAuth client, we already saw that we can create the OAuth client and then configure it. So we already are done with these steps. So in case you are doing it from the command line, you will need to take care of doing a basic for encoding of the secret, and then first make a curl request to get a token. So I'm already doing it via the Postman. So otherwise, if in case you are doing it from the script or you want to do it from the console, you can first get a token, and then once you get a token, you can use it then to post do a post request to submit an order. Okay, so in my case, the request was passing, but that will not be the scenario for you. Yeah. And there is a reason for that. The reason being that, as we saw in the diagram, in the initial diagram, there was a mock host to which we are submitting the external order. We are just doing some mock processing there, just for the purpose of demonstrating the various capabilities. And currently, that mock host, when you will be doing this session, it will not be deployed for you. So you will see an error occurred kind of a message. I will simulate the error in my case just to show you that what will exactly be happening. So I will edit the config map that has been deployed to change the mock host to have something invalid. So let's go ahead and then change the URL. Now it becomes an invalid URL. I will need to restart my CAP application so that the changes in the config map take effect. So this is just for a deployment part, just for a demonstration part. In your case, you will actually see the actual error coming by itself when you reach this step, because the mock host is not currently deployed for you. So let me just confirm the new CAP application is now up and running. Yeah, it's running for 23 seconds. And now if I make a request with the existing token, So I'll see that I want to create a next order. So I'll see an error occurred because my mock host is not currently existing. So the, in a microservice architecture or in a set of distributed systems, this is a very normal kind of a scenario that can happen in actual setup. You might have different dependent upstream services to which you are making an API call or connecting to them, and then for whatever reason, because of the network partitioning, because of some other possible cause, they might be unreachable or they might be down. So when you build microservice architecture, you need to ensure that you have the appropriate measures in place so that you can react early to solve these kind of problems. First of all, you should be able to become aware that such a problem exists, and after that you should be able to identify and fix the issue as soon as possible. So this is where we'll be using the alert notification service to ensure that when such an error occurs, you get an alert for that, and once the alert is there, you should be able to react on that and then fix the possible errors. Okay, so now let's go ahead and then configure the alert notification service. So in the alert notification service, we are basically, as I mentioned, you will be using this resources alert notif deployment that will create an instance of the alert notification service and also deploy a serverless function inside the Kyma runtime that will then send the alerts to this service so that it can process it and then forward it to the appropriate notifiers. For example, it can notify it to your email ID, or maybe for certain other criteria to certain other ways of notifications. So let's have a look at this alert notification deployment YAML to see that what all changes are required there. So I'll just go back to the main branch to see that how it's gonna look like exactly earlier. So you will see, you will need to provide your email ID here as a destination. So provide your valid email ID. And after that, you will need to provide the region in which your sub account and your Kyma runtime is running. So there are instructions in the documentation how to understand or how to find out in which region your sub account is deployed. You can check it from there. You need to provide it all in caps, and then you need to provide the cluster domain of your URL. You will see that we will use a cluster domain to generate a URL for the Grafana logs so that it makes it easier for the SREs and developers to directly get navigated to the appropriate logs and then understand and quickly troubleshoot and fix the problems. So once you do those changes, it's gonna look like a bit this, your email ID. And then in my case, my cluster is running in the EU10 region. So I provided that, and then this is my cluster domain. And then the rest of all, we have the serverless code just as a part of a deployment YAML. So this is one way of deploying the serverless function, but you can also configure a Git repository so that the serverless in Kyma runtime can automatically pull the code and then deploy it as a function on your behalf. So you will do apply for this, and it will go ahead and then create all those resources. So it will also create the service binding for you. So it will create a service binding so that it will create the secrets required for the alert notification, and then it will create a service binding usage. With the usage, it will bind the secret and the keys to this particular serverless function. So you can see that we have a service binding ref, and then we have a used by serverless function so that the secrets then become available to this serverless function as the environment variables. So if we look at our serverless function to see how it looks like, I will go to the functions and I'll go to the alert notif part. So here we are using the auth authentication for making a call to the alert notifications URL. So we need to get a token first, and after that we will create an alert notification client. And then we'll process the alert. So the client will then send an alert event to the alert notification service. And here we are using the cluster domain to create a Grafana URL. But the main thing is I wanted to show you how these environment variables are getting injected into your serverless function. So if you go down there, you can see in the environment variables, so some of the variables are provided by us, but the other variables like client ID, client secret, and auth URL, they are coming from the service binding. So when you did a service binding usage on the via the YAML file, it will automatically inject those secrets into your serverless function. The same functionality also works when you deploy the microservices. So you can have a microservice and then you can do a service binding connection or a usage, and then it will automatically deploy or inject the secrets as the environment variables into your microservice. So this finishes our whole part of deploying the alert notification. So when you do it first time, you will get an email asking you to confirm that you should be able to receive the alerts. So when you do the confirm, I just need to open my Outlook, because in my case, yeah, I should be able to see the alert there. So let's see that if we have got the alert for that. Yep. So if you see just now, so this is the alert we got when I simulated that error, and then I can see that it contains the various details. It contains the details of my global account, my sub account, my resource group, and all the other resources which I configured when I created the alert event. And but the main thing is it also creates this details link with which I can navigate directly to the logs, and then I can see what actually went wrong and how I can fix it. So if I click on this link, so I am able to see the logs in the namespace cap. So if I go down there, and yeah, if you search for this message, you can see that the error not found. There is an invalid address. Like I'm able to realize that this address, this internal host name either doesn't exist, or is it invalid, or there is a typo in my case. So I should be able to now fix it and then move forward. So in my case, I will now go ahead and then edit the config map. And simply restart my application so that it's able to then pick up the latest configuration. And let's see, I think it should start pretty quickly. Yeah, it's just going to start. So I can see that it is up and running. Yeah, so far so good. And now if I go back and then try to create a new order entry here, I should be able to do it successfully. Yep. So this is just a simulation of how the problems can come in a microservice architecture in a way that when you deploy your cloud native applications on Kubernetes, which are dependent upon other services, and then how you can identify them using some of the SAP's BTP services, for example, the alert notification, and then how you can then use the various observability toolings coming from the Kyma runtime to quickly troubleshoot and then fix such problems. Okay, so we are done with the alert part. And yeah, so we just need to follow that and do it there. In my case, I've already done this modification so that my CAP service is aware that there is a alert notification service that exists. So that's why it was able to forward the alert, and then the serverless function was able to generate the alert event, then which in the end send an email to me, so that I was able to identify the problem, first get notified, and after that identify the problem and then fix it. Okay, so the last part is deploying the mock application. So again, the mock application is deployed as a Keema serverless function. So in this case, we just need to deploy this mock application, the deployment YAML file. So if you look at this piece of code, it's a serverless function, and it just contains the basic code to do some random work and then create just to do a mock order creation. There is nothing much happening there, but just as a part of showing that you can have an upstream service call, and then how you can basically build a kind of a multiple microservice architecture so that you can communicate with the different services for implementing a scenario. If you want to test it locally, you can expose it via the API rule, and then you can follow this URL to post the order. But in my case, since we are already doing it via the CAP service, so yeah, we were able to follow this step and then to create an order. So once you create the order here, it also gets reflected in your HTML5 application. So in my case now, if I refresh this, I should be able to see the new order being reflected here. Yeah, so 2, 4, 3. Yeah, we are not doing the validation for here for the same kind of order ID, but you can add it there as a part of your CAP application. And you can see that it gets reflected here in my the HTML5 base site where I'm getting all the orders. So that's pretty much what covers the whole setup. And I think we are at the end of this and we have some time left. So we can take a few more questions, I believe.
I think we're good with regards to the questions. So one, we need to follow up later on, as I said, or as I posted in the chat, and we will create a blog post on the BTP Kyma Runtime tag to post the Q&A afterwards. I mean, I can read it out loud. Maybe you know the answer. It's about the API gateway and OAuth, securing APIs by OAuth. So some OAuth setups require next to the scope parameter also a resource parameter. For example, when setting up a connection with Azure Blob Storage. This is not supported so far by the Kyma Runtime, is it? Or is it on the roadmap? To specify not supported so far in BTP, Nico means in destinations in BTP, and he didn't see it in the wizard of Keema either. Would you know this on the spot? Otherwise, again, we will reach out to the product owner.
I think we can take it offline. I might need to write a text a bit more, so I'm not fully able to imagine what's there, but I think we can take it then offline. Yeah.
So as I said, I mean, we will get the answer and then post it in the blog. And is there a GitHub repository for similar Java or Spring Boot example?
I think there is, and we can basically find the link because there are some tutorials about building the CAP applications on the Kyma runtime, and one of the tutorials do contain a Java-based application.
Okay, so let me maybe put 2 more links in the chat. Our samples on GitHub and as well the developer tutorials. Okay, so then one more question. So when we say serverless, then how can we create a banking application in India? Because the server should be physically located in India. So for that, have a look into the regions of the BTP Kyma runtime. I posted the link earlier in the chat. It's as well in the help portal. Let me look it up again, because we support one, if I'm not mistaken, it's AWS region in India. So you can create the Kyma runtime in India. So if you look into the help portal, let me just double confirm this. Yes, so AP South 1 of AWS is in Mumbai.
Yeah, I think maybe one thing to add here, I think the understanding I got from the question was that they might be referring to the serverless. It means that it's running somewhere else, but no, when we say serverless, you actually create the functions in a serverless fashion that you just provide your code, but the actual deployment happens inside your Kyma cluster. So if you look at this particular function, this alert notif, just to give an example, the actual function is again deployed as a pod inside your Kubernetes cluster. So it is again running inside your Kubernetes cluster where in your region which you identified and deployed. So if you identify the region as India, it will then be running inside this particular India region. So it won't be running in some other external service like in some Azure or somewhere else. So the serverless is basically it's a helper feature to help you easily build up your functions and then deploy the code without worrying about creating a Docker image. But behind the scenes, we take care of creating a Docker image and then deploying it for you, and it then runs inside your Kubernetes and Kyma cluster in the same region.
Cool, thank you. And then another question is, can we suggest persistent volume claims for productive scenarios? Meaning to ask, if a pod destroys, are we still able to access that persistent volume claim? And if not, is there an alternative way?
Yeah, so you should be able to use the persistent volume claims for doing for any kind of storage purposes, and they are in fact meant for that particular purpose. Whenever the pod gets either restarted or recreated, which is very common in the Kubernetes world, because the Kubernetes scheduler can decide out of those nodes, if one is running out of capacity, it will try to do some rescheduling. So the pods will be restarted. And then if you're using the persistence volume claims, your data will be persistent. It won't be lost because of those pod restarts. That being said, always ensure that in case you have an alternative of using a database or application service coming from the BTP, please consider using that first, because then you don't have the overhead of maintaining or operating a database by yourself. But you can still use the persistence for any kind of a storage there.
Cool, thank you. And then again, the question with regards to if this Q&As can be accessed after the session. So again, let me just post the link to the question. So this chat log won't be persisted. We take care that we take a note of that and all the replies, and then we will work on a blog post in the next couple of days to post it to blogs.sap.com. So let me just post the link again as a reply to that. Is there a complete flowchart that we can easily follow for the end-to-end scenario for the setup? So Danny, if you mean the setup of this session here, then this is all documented on the GitHub page, which is linked here as well on the page of where the stream is happening, like at the bottom, session materials. But let me send it as well to you in the chat. Is there any, question to you, Gaurav, is there any formula or any way to query Grafana to retrieve the average CU, so I guess CPU consumption of a pod and replicas in the Kyma runtime?
I think that already exists. So if you go to your Grafana dashboards, so you should be able to look at some of the Kubernetes resources like the pods. So one of them should be able to give you the CPU usage. I'm seeing it currently for the node level, but I know for a fact that there already exists one for at the pod level, and you should be able to simply access it. So for example, here you can see the CPU usage for all the pods in a node, but for the deployments, you should be able to go to the particular deployment and then check it there. So let me see if I can see the pod there, maybe here. Yeah, so you should be able to, for example, look at the CPU usage currently there. So how much is configured, what are the limits, and then what is the request there. Yeah, so same thing for the memory also, you should be able to see the memory usage and the memory request percentage that is being used. So you should be able to see that how your pods are behaving with respect to the resource consumption perspective. So yeah, I see that Amrusha has raised a hand. Amrusha, do you want to jump in or say something?
So maybe in the meantime, just a few things. So I posted some follow-up links in the chat as well, like our missions in Discovery Center, for example. Just newly, there's a mission on how to deploy a multi-tenant application on Keema in the Discovery Center. So I posted the link there. We have as well the developer tutorials on sap.com and the samples, like more samples on github.com. So do that as well, look into that as well. Then for all the partners joining, so there is a pay-as-you-go offering for test demo development purposes offered to partners. Keema was just made available inside that offering as well. So it's a pure pay-as-you-go for TDD purposes. It's really made available this Tuesday. Today there will be the announcements in Partner Edge. So have a look into that as well if you're a partner company to SAP.
And so the sample space which Mark was referring to is Kyma Runtime extension sample. So we have samples in covering various scenarios and various technologies. You have samples with the front-end React, with running a database on Azure and then connecting it via a function or a microservice running on Kyma Runtime. Then you have scenarios around the S4 Hana. You have scenarios with various technologies like the event triggers for the Cloud SDK for Java or a Cloud SDK-based Java application. You also have some scenarios for Scala, and then there is an extra interesting scenario for the user propagation. So in case you are interested in propagating the user context across your extension to then the SAP application, you can refer to this scenario. It currently works with the Cloud for Customer, and then when you make a call from your mobile application or whatever front end to this extension, and then when it interacts with the Cloud for Customer, then the user context is propagated so that all the actions are happening on behalf of that particular customer. Similarly, we have a WebSocket scenario. So in case you're interested, you can refer to that for building some WebSocket-based user interfaces or applications. And then, yeah, there is a CAP service example also, but there is a one for Java also. And then I think we will follow up and then share the link with you.
Samrusha, I think with that, we would be at the end of our walkthrough.
So yeah, then I will hand over to Amrusha for technical host. So thanks for all the support.